So hello guys, welcome to my video of the playlist called C# for Beginners. Okay, so remember back quite a few lessons ago now when we first looked at list string and dictionary string int. At the time I told you those angle brackets were something called generics, and I say don't worry too much about it for now. Well, now it's time. Today we are actually building our own generic code, and once you understand how this works, honestly, a lot of C# is gonna suddenly make a lot more sense in hindsight. Let's start with a problem. Say, we wanna build simple little box that holds single value. Could be useful for all sorts of things. So let me show the code. For example, integer box, public int value, get that class string box, public string. Okay, see what's happening here. These three classes are structurally identical, same property, same idea. The only thing that's actually different is the type. And if we need a bool books to we'd write basically the same class for a fourth time. Yes, this is exactly the kind of repetition generics were built to eliminate. So instead of writing separate box for every single type, let's write just one box that works with whatever type we hand it. Class box type in T and then public T value. Get that. Let's slow down on this because this one line is doing a lot. Class box T, that T right after the class name is what makes this generic. T here is not a real type at all. It's a placeholder standing in for whatever type gets decided later. When someone actually uses this class, by convention, T is standard letter used for this, short for type. You'll see it constantly in real C# code, though technically you could name it anything. And notice inside the class public T value gets set, same auto property syntax, we've used it 100 times by now, except instead of int or string we just use the placeholder T, right? So let me show you the code here, how we can use it. Box int and then maybe int box equals new box int, done. And then you can say int dot value, int box dot value equal maybe 42, and then box string box new box string box dot value equal maybe hello box double box equal new box double box dot value equals 3.14. Yeah, done. Okay, and here's the payoff. Box int, that's us telling C# for this particular box, replace T with int everywhere it appears. Box string does the same thing, but with string instead. One single class definition, and it's flexing to fit whatever type we actually need on demand. And here's the part that really matters. This is not just convenience. It's actually safe. Watch what happens if we try something we shouldn't. Let me show you. For example, we created our box integer, yes, and its type is integer. So what if we do something like that? Int box dot value equals maybe some string banana. See that? It's compile time error. C# now enforces at compile time that value can only ever be an int for this particular box. This is actually a really important point, and it connects directly back to something we touched on the collection lesson. Remember why? List string would not let us add a number into it. Exact same mechanism right here. Generics give us reusability and type safety at the same time, which is honestly a pretty rare combination to get for free. Now, generics are not limited to just classes. We can apply the exact same idea to a single method without needing to make the entire class generic. So let me show you with methods. Void, maybe print twice. And we're gonna t value, t item, item console, not right line, item. Yeah. And then print twice, integer, 5, print twice, string, hello world, print twice, double, double, just right points. Okay, now let's run this. 5, 5, hello world, and 3.40, 3.40. Same idea as before. T right after the method name declares it as generic, and the T item accepts a parameter of whatever type we decided. Notice that last call print twice and 3.40, no double written anywhere. Yeah, C# is actually smart enough most of the time to look at what we pass it in a int and figure out t on its own. This is called type inference, and this should sound familiar. We saw the exact same idea way back with the var keyword. Remember, same underlying concept, just applied here to generics instead. So let me show you one example also. So we can find max, and then d first, d second, where d, oops, I don't here, where t I comparable t. Okay, and then we're gonna write return first dot compare to second 0 first second semicolon, semicolon, yeah. So dot red line find max console dot red line find max apple banana. Okay, don't worry about the name where T I comparable part just yet. I'm actually about to explain exactly what it means in a minute. It's not our topic. It's our next topic, okay? Not for today's, but look at what this method is actually doing. It works for numbers and it works for strings, comparing which one is bigger, all with a single method definition. That's a genuinely powerful, yes? So let me run this code. I think you are seeing the terminal, right? Oops. Clear? Okay. As you can see, 25 and banana. So, alright. So that very close, I skip it past. Let's actually dig into now it, okay? Because it solves a real problem. Here's the thing right now. T could be literally anything. And sometimes that's actually a problem because not every type supports every operation. For example, um, if we did with the types that we couldn't compare, okay? C sharp genuinely has no idea just from T alone. Whatever type gets used here actually knows how to compare itself to another. So sometimes it can, but what if someone passed in a type that can't? This is exactly what generic constraints are for. They let us say T can be anything as long as it satisfies this specific condition, okay? So that's why we are saying here T should be I comparable, right? The where TI comparable remember the interface from a couple lessons back. Yes, this is just saying T is allowed to be any type at all, but it must implement a comparable T. It just implement so happens both int and string along with most of C Sharp's built-in number and text types already implement that interface, which is exactly why our earlier example worked fine for both. Okay, now constraints are not limited to interface either. There's a few other common ones worth knowing. So let me show you. Okay, look at here, class container maybe, and it can be C type where C class. Okay, public C item get and set. C create instance the instance return new key. Okay, void feed the animal where the animal. Oh, animal. Okay, return. Oh, return. Right, not console dot writeline. Uh, feeding feeding the animal animal. Okay. Look at here, where T inherits class restricts it to reference types only. So classes, not structs, okay? No, only classes. That means it should be exactly class type. If it gets inheritance, I mean, if it's type like the integers or something like that, that means it does not work here. So, and then inside constructor available, so we can safely create new T inside our method where T inherits from animal, assuming that we had a class animal, right? We have animal and restricts it to only be animal itself. So it should get inheritance from animal or something that inherit from it or animal itself, tying right back to inheritance from a couple lessons ago, right? Honestly, you don't need to memorize every single constraint option today. Just know they exist and that they let you say its generic code needs some guarantee about T can do rather than accepting absolutely anything. Okay. One more thing worth showing, and this is one is was not explicitly on today's list, but it comes up naturally and honestly you've actually already seen without necessarily realizing it. Remember dictionary, string, and int from the collections lesson, right? That's a generic type with two placeholders, not just one. We can build our own version of that idea too. Let me show you. Class, here, E first, E second, public, public key first get set public key second get set pair string int name and age new pair string int first Alex second Tony. I put here. Yes, works. And console dot writeLine name and age dot first is name age dot second years old. Okay, let's run this. Alex is 20 years old. See that pair T first, T second, two separate placeholders this time. Each one, let me show that. Okay, each time, each one fill it with independently. Yes, this is genuinely just exactly same idea as dictionary TK and T value under the hood. Now you know how something like that is actually built internally rather than it just being magic that C# hands you. Okay, so to bring all of the things that we've learned today, I'm gonna show you with a small example. Okay, maybe class repository. Class repository D where D in her oops get in her class private list D oops going on D list D items equal new list D. Okay, public void add D items dot add item and then public D gets first get first turn items dot count items no public int count return items dot count. Okay, and now we need class maybe product oops what's product public string name get set and then repository of product repository of product repo equal repo equal new new a new repository product. Okay, repository product repo dot add new product new product name equal maybe laptop and maybe mouse here, mouse. Console dot write line product repo dot count console dot write line product repo dot get first. So let's run our code. To and product, yes, get first. Uh, we should get actually here name. That's why we are getting that product here. It's name. Yep. As you can see, to and laptop here. To and laptop. Okay, good. And here's the nice realistic example. As you can see, the whole code. Uh, we are using the generic repository T class constraint to reference types internally using a list T. Remember, list is a generic tool to store whatever type we plug in. Today, it's storing a product object, but this exact same class, unmodified, could just as easily manage student or order or anything else. That's actually the whole promise of generics. Write it once, reuse it everywhere safely. So that's all for today's generics types. So I'm gonna give you a mini challenge conventionally. So your challenge would be building a generic class called stack, T type in T type, just a simple wrapper around the list T internally with a push item and method to add something and pop. Method that removes and returns the last item added. Test it out with both integers and strings, okay? So today we covered generic class using them with different types, generic methods, and type interface generic constraints for restricting that T can actually be. And bonus, look at multiple type parameters like we see in dictionary. Generics are genuinely one of those concepts that quietly powers a huge amount of C#'s built-in collections and libraries. Now that you understand how they work, a lot of code you've already been using is gonna make a lot more sense. Next time we move into delegates and lambdas, a totally different, really powerful way of working with methods themselves as values. See you there. Take care.